So let's just review that and think about graded potential. So they're initiated by a stimulus. They are small changes in the membrane potential. Their magnitude can vary. So they're not going to have a fixed magnitude the way that we see for action potentials, but they can be of varying degrees. They can be small, they can be medium, they can be large in terms of their strength or magnitude. They basically spread by electrotonic conduction, and this is where the electrical energy or stimulus moves from the point of where it's triggered further away by electrical conduction. So very similar to the way we have that electrical current moving in a wire, that is the same degree or the same type of movement that we see as that electrical energy spreads from the point of stimulus more distal. They're going to be decremental. They're going to decay or dissipate as they move away from that stimulus. So as we can see here, the graded potential begins at the synapse where one neuron is releasing its chemical that is triggering another neuron to initiate the graded potential. And as that moves away from the point of stimulus, it becomes smaller and smaller in magnitude. And if it is not enough to maintain -55, it completely dissipates and we never actually have an action potential. So here is the stimulus site. So the membrane potential change at the site of stimulation versus the membrane potential change at the axon hillock. And notice that it's a much smaller value as that decays or dissipates when it moves away from the stimulus. Now, when we think about the threshold, this is the level of depolarization that is required in order to begin an action potential. And when we think about the word depolarization here, we're going to start to use this word a bit more. This is an excitatory change in the membrane potential. So when we depolarize the neuron, we move it away from its resting potential, but a change that makes it more positive. So this is going to be an upward spike in the membrane potential. A hyperpolarizing event or hyperpolarization is going to be in the opposite direction. This is a negative change in the membrane potential. It goes from being -70 at rest to -80 or -90, which is a decrease in the membrane potential. In other words, it's going to be an inhibitory event as opposed to an excitatory event, which is a depolarizing change. So depending on the direction of change, that will determine whether we have an excitatory or depolarization event, or if we have an inhibitory or hyperpolarization, which is decreased. Now we can think about temporal and spatial summation. These are two mechanisms to add smaller graded potentials, and this can help us achieve that threshold -55, depending on the number and type of events that we have preceding, the number and type of graded potentials. So if we have two depolarizing or excitatory graded potentials, and they're both happening close enough in time, that can be added and result in temporal summation. So they have to come along close enough in time for them to be considered and to be added to generate a stronger graded potential. Another mechanism is if they overlap in time and they're on the same spot. So this is going to be spatial summation. So they're happening at the same time, but they're happening on two different spots on the neuron, and they also can be summed to result in a stronger graded potential. So in this scenario, because we actually have a hyperpolarizing event and, or excuse me, a depolarizing event and a hyperpolarizing event, we can add those together. They're coming in at the same exact time, but they're on slightly different spots on the neuron. So different stimuli, same time. And if we add those together, that would be spatial summation. In this instance, they're going to cancel out, right? Because one is positive and one is negative, they're simply going to cancel out. For the temporal summation example, they're both positive, and because they're same stimulus, but close enough in time, so kind of one right after the other, we can add those together, and they're both going to sum to give us a stronger membrane potential change, which gets us to threshold, and then we fire an action potential.